Alright, ke na question on a vertical projectile motion. This is question 3 uvela November 2018. In the description box you'll also find links for other questions engwaphendulile for the same question paper esiphendulayo manje. Question 3. Bathini stone A is thrown vertically upwards with a speed of 10 meters per second from the edge of the roof of a 4-meter high building as shown in the diagram below. Alright, again. There's someone lana who posa a ball upward with an initial or a speed of 10 meters per second upward, right? Umile at the edge of the roof, which is 40 meters high, right? When measured from the ground, this is the ground, the building is measured from the ground. Ignore the effects of air friction. Take the ground as reference. Very important, very important. You need to have a reference whenever doing our calculations go vertical projectile motion. 3.1, define the term free body free body diagram. Okay, this is not Newton's law but the vertical projectile motion. Free fall, define the term free fall. For 3.1, if free fall now push the object upward, since lana see ignore the effects of what, of air friction, it means the only force acting on that stone, the force of gravity. Motion during which the only force acting is the force of what, of gravity. Free fall. 3.2, calculate the maximum height above the ground reached by stone A. Okay, so le stone abasiphosela phezulu sizothatha a path like this one. So basiphosela phezulu le stone sizofika to a height called iluga maximum height here to somewhere here, right? But bathini calculate the maximum height above the ground, right? Uma bathi above the ground bachaza ukuthi, okay, well, this is the maximum height, yes, but what is the maximum height above the ground? So chaza ukuthi kwamele add the even nalo 40 lo. We have to add this 40 meters. So in other words, the max height measured from the ground, so max height when measured from the ground is this small h plus the 40 meters height, right? This is the height, so the maximum height, so th plus 40. So now so keep it data and choosing up as a positive, choosing the upward direction as positive. We want to find delta y, or the small letter h, which is the maximum height reached by the ball when thrown from the edge of the building. Initial 10, final siyazi ukuthi nayifika at the maximum height the velocity kuyoba 0 meter per second. Gravitational acceleration, it's always 9.8, but in our case it's a negative because we chose up as positive. So from our equations of motion, so inside this equation choose this one because of final velocity, initial velocity. I also have a gravitational acceleration, yes. I also have what, delta y, which is the unknown, right? So the other three must be known. So the formula basically in allow to calculate delta y with all the other values in the formula known, right? So enza kanje ke manje sizothi we substitute, and then after substitution it's 0 squared final velocity 10 squared initial plus 2 in bracket minus 9.8 times delta y. Okay, then delta y, making with delta y the subject of the formula, you told with it 0 squared 10 squared, I think it calculator, so it's 0 squared okay, let's put it in brackets. It's not like it will make any difference if ngifaka ama brackets. So ngifuna ukuthi ama teachings wami abe consistent ngoba I like ukuthi uma wenza substitution at least put ama values wakho in ama brackets, right? In ama brackets. Why ngisho njalo? Because of sometimes i-calculator man inokuba dumb man. Let me show you something. So our answer is what is 5.02, 5.102. So delta y is 5.102 meters, right? Now let's say the answer yakho la, well, not the answer yakho. Let's say mhlawumbe ufuna calculate something like z2 squared plus negative let's say negative 6 squared, and then thola ukuthi the answer yakho bani ulokanje u40, right? And then someone athi no mina angifaka ama brackets avele athi so avele athi maybe athi plus la, and then abuya athi lana no bracket as well. Answer it's negative 32. Yabona there's a difference la, there's a difference. So be careful. That's why ngithi always substitute when I use the substitution in a formula, put ama values wakho kuma brackets, right? Anyway, now this is our maximum height, or delta, or not delta but small letter h. So the value kumele si calculate na again. So the maximum height is equal to, this is h, is what? Is 5.102 plus 40. The answer is what's this? 40 plus 5.102 is 45.102. There was no need for me to calculate, but anyway, nice. Itolile. It's 45.102 meters. Yes, 3.3. Banyakangmo bafunan. But write down the magnitude and direction of the acceleration of stone A as it at this maximum height. Right? Write down the magnitude and direction of the acceleration of stone A at this maximum height. That's what we calculate. It's equal to 9.8 meters per second squared downward. The gravitational force is always acting down. It's always acting down. Whether you are phezulu, you are phansi, gravitational acceleration is always acting downward, and the value remains constant as 9.8. Okay, now sesilana ke ku 3.4. Stone B. No, stone B manje. Yes, stone B is dropped from rest. Yeah, okay. Stone B is dropped from rest from the edge of the roof X seconds after stone A was thrown upwards. So 9 guy. Stone A ngiyamthatha ngimphonsela phezulu. After some time ngidropa ubani stone bani B ngiyamdropa. So sifuna ucalculate lesikhathi where stone B was dropped. In other words, yes. So into engizoyenza ngizo-erase lana so that we can do this calculation at 3.4, where bathi stone A passes stone B when the two stones are 29.74 meters above the ground. Calculate the value of X. Okay, now 3.4, let us start by choosing a direction. Let us choose up as positive. So by choosing up as positive, basically in Kazuguti, everything going down is over negative, right? So as we look back to the statement, the stone B, there's a stone B manjela. there's a stone B. Nangu B. Ngimbambile u-B la. Ngicala ngiphosa ubani stone A. I don't know it's before the maximum height or after the maximum height where stone B is being released, but yeah, now stone B is released after some time. After some time, which is X seconds. After X seconds, stone B is released again, right? Release. So stone B is dropped from rest from the edge of the roof X seconds after stone A was thrown upwards. After X seconds, boom, B is drop. Stone A, now stone A, after lama X seconds now kuge stone A wiphindwe yabuya kumala. And then akamala point B naye. Okay, I think it so that there's a clear or some clear understanding. Now point B after some seconds, right? After some seconds or some time later, now get stone A now stone A no stone B. Stone A passes stone B, but stone A udlula ubani stone B. But ngathini at this point they meet, right? At this level they meet, B no bani no A. But no stone A passes stone B when the two stones are how many meters? 29.74 meters above the ground. Calculate the value of X, right? Which is the time when B was being dropped. So 90 so yens agela. Let me erase. I think erase now. Let me erase. Okay. Now ngizodinga displacement from roof to the meeting point. This displacement is also with this calculator ubani X seconds. But first let me elaborate a little further nyan. Bega ke manje. Stone, well, in fact both stones ayagupi, they are going in the downward direction. So uma aya in the downward direction, it tells ukuthi the path abazoyi travel both stones A and B bazosuka from this point all the way to the ground, right? Uma aya both all the way to the ground, the height of the building is represented displacement for both stones. So it's going to be minus 40 meters. Now sugar from top to the ground, I'm going in the negative direction. So that's why I see about a negative 40, and then the plus 29.74 is the distance from the ground to the point where the two meet, right? I'm going the displacement from roof to the meeting point, which is this distance from La to La. So by adding the two displacements in Tola, the net displacement La, which is represented by the black line, right? This line. So it is so by adding minus 40 no plus 29.74 is only that value. Is only that value, which is equal to, let us calculate, minus 40 plus 29.74 equal to negative 10. Negative 10.26. Yeah, negative 10.26 meters, right? So saying that displacement again, right? Saying that displacement, but okay, the logic of the calculation is in fact to calculate iskati so travel stone A all the way to the point where the two meet, where the two balls meet or the two stones meet. And then it's calculating iskati saga B. Nesikhathi saga B asithethe from from the edge of the roof all the way to the point where azometer ubani stone A at this level. So for stone A sizoqala ngaye calculate the time taken by stone A. Zoba ubani let's keep it data kuqala. The initial velocity to 10 is for now delta t. The time taken by stone A to come to this meeting point, and then delta y is given is what is the displacement, right? Is the displacement from where? From la edge of the roof all the way to the point where they meet. Displacement is from la to la. The path traveled by stone A, this curve nyana, is called the distance. There's a difference. This path is called its distance, and then the displacement is from edge all the way up to here, which is represented by negative 10.26. It's a negative ngoba the downward direction is a negative direction. And then substitute sizothi, so sebenzisa which formula? This one, delta y is equal to v initial times t plus a half g delta t squared. So the value lana ubani negative 10.26 equal to initial velocity 10 delta t plus half negative 9.8 delta t squared. So lana, what do we have? Okay, I've calculated this one. Half, which is 0.5 times 9 minus 9.8. Answer negative 4.9. So lana it's negative 10.26 10 delta t minus 4.9 delta t squared. So we have a quadratic equation lana, and then let us rearrange or write this equation to standard form. About minus 4.9 delta t squared plus 10 delta t plus 10.26. Then we substitute. Let's see, it's negative open bracket b over 10 plus square root b squared 10 minus 4a over negative 4.9 c 10.6 close bracket 2a minus 4.9. Answer. So the first solution, you have 0. Okay, time cannot be a negative quantity, so answer the next value here. Let's see the next value. The next value 2.79. So this is our answer. T is equal to 2.79 seconds, which is the time taken by what? By stone A. Now for stone B, space. So let's do this. Okay, I send the so go, and then as for where now, let us erase now. Let us erase. Here we go. Come on, man. Come on. Okay, so into it's just to write the calculation, do the calculation page while the question paper. Space. But anyway, for stone B, 9 this way skip it. Okay, there's no need to take out the data, or should we? Initial velocity for stone B about 0, still choosing up as positive, and then final velocity angnayo. If you realize now now stone A final velocity angnayo la, right, is not given, since the meeting point of us shailing my final velocity corner. So for stone B na corner I don't have a final velocity, but g is minus 9,8. And then what else? I have a displacement minus 10,26 meters. What else do I have? ngifuna uthila, ngifuna delta t. So I think even for, okay, this one is over simple again. Avoid a situation where kumele ngisebenzise quadratic formula again. Nah. Angithandi quadratic formula. But anyway, lana it's g delta t squared. So sebenzisa this one again, minus 10,26 equal to initial velocity 0, so it means lana it's a 0 plus 1 over 2 g over minus 9,8 delta t squared. So lana it's minus 10,26 equal to minus 4,9 delta t squared, and then you divide both sides and take the square root. So it's tizela, so it's negative 10,26 divided by negative 4,9 equal to, then okay, bese ngizothatha the square root of my answer, which is what, 1,45. Delta t is equal to 1,45 seconds. Boom. Now bheka ke la, the x is over equal to, bheka ke, u-a uthethe how many seconds? 2,79 seconds. Wezala. And then u-b uthethe how many seconds? Uthethe 1,45 seconds. So the difference between lesikhathi lesi nalesikhathi lesi izosipha isikhathi saka x. So therefore x is about 2,79 seconds minus 1,45, which is equal to what again? Which is equal to what? 2,79 minus 1,45. Answer is 1,34 seconds. Nayi answer yethu ke. Mnganakho uthethe 3 hours ukubhala iphepha, right? And then wena uqale x hours after umnganakho aqeda ukuqala, wena nomnganakho wena nomnganakho niqedele phepha. Okay, ngithi ngizama create an analogy la, just to make this this calculation, just to bring some clarity to this question, or to this calculation ga x lena. I can't think of one right now, but the idea lana is to subtract from the longer time, so that uzothola lesikhathi la uloga stone b asuke ngaso khona. So this concludes our 3.4. There's another question lana which I didn't show before ngizo continue nale recording la lena, but let me erase. There's a second part of this equation. There's another question which is the last question for question 3, but let me erase qala la. Okay, nazo ke 3.5 sakhuluma ngala ma stones wethu, the graphs of position versus time for part of the motion of both stones are shown below. This is the position, the y-axis, and then the x-axis is time. Which of labels A to H of the graphs above represents each of the following? The time at which stone A has a positive velocity. Ikuphi ke la? Bheka ke manje. Sifuna the time at which stone A has a positive velocity. So nangiyaphezulu I have a positive velocity. Nangabe ngiyaphansi ngiyakuphi, I have a negative velocity. So bheka, at time D I'm going up. I think even at let's see, Okay. I think at time E I would be wrong to say lana. Interesting. Okay. Before ngiphendula la, the motion of both stones now low A, definitely stone A, and then low stone B. Uyabona bamdrophile again, right? So the time at which stone A has a positive velocity, it's definitely D la. 3.5.1 kuzoba D, since it's going up, and then ku E, as uyabona la ku E we have a maximum what? A maximum height. So I don't think lana it's a positive nor a negative velocity, but the positive velocity is sithola somewhere la ku D. And then the maximum height reached by A ubani the maximum, let's be careful. These are times, and then these are the positions. So now basibuza ngeposition, the position or the maximum height reached by stone A ubani A, the maximum height is A for stone bani A, 3.5.3. the time when stone B was dropped, obvious nyla, this time at F is drop our stone bani, drop our stone B ubani F, which is the time is calculated with 3.5.4. The last question, the height at which the stones pass each other. the height should ubheka ku position, time should sibheka la ku time, maximum height sibheka kuphi la ku position. So it's easy to get lost la, but anyway 3.4, the maximum height, the height at which the stones pass each other ubani point or position C. So our answer is C lana. 3.5 concludes our question or our lesson for today. So question 3 uphelela lana for this November 2018 question paper, Physical Sciences paper 1. In the description box uzothola ama links for other questions engiwaphendulile. So for now, asilike, asicomment, asishare if uthole some value out of this video. Nangabe une question, let us discuss in the comment section. For now, thanks for watching, and yeah, asibonani on the next video. Peace.